Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, I think I will conclude with a test for Algebra 1, the Regents exam, that was offered in January 23, 2019, a 3-hour exam, as you know, 4 parts as usual. So again, today I will do part 1, and then I don't know if we finish the remaining in 1 or 2 days. So let's start and don't waste time. The first 24 questions, of course, each one is worth 2 credits, as you know, multiple choice. So they tell you the scatter plot below shows the relationship between the number of members in a family and the amount of the family's weekly grocery bill. So the most appropriate prediction of the grocery bill for a family that consists of 6 members is how much? And usually you try to fit, it's not going to be perfect, but a straight line that goes in the middle of the data. So something like that, right? So if I draw a line, something like that, we'll have pretty much have the points above and have below close to each one. Maybe it wants to turn a little bit, but at 6 you will get something according to this line. Each one will have slightly different line. You get roughly what, 280 or 90. So 300 would be the most likely answer, and that should be the correct answer. 100 is very low, 400 is much higher, and 500 of course very high. So 300 is the one that makes sense. Now let's move to the second one. It says the function g of x is defined as negative 2x squared plus 3x. The value of g of negative 3. Please remember, g of negative 3, meaning every time you see the variable x, you replace it with by negative 3, and always make it a habit to include that between parentheses. You see, even the negative 3 is between parentheses. So that's what we are going to do. We are going to say g of negative 3 equals negative 2 is a constant, and then I have an x. So negative 3 squared plus 3 times x. No, it's not x, it's negative 3 again. And now this would be negative 2. Negative 3 squared is positive 9. And 3 times negative 3 is negative 9. This is negative 18 minus 9 is negative 27. So it's 1. I was going to pick this. Okay. Which expression results in a rational number? Rational number is something that you can write as a ratio, right? Ratio, rational. Okay. If you know your complete or perfect squares, you're in good shape. So for example, I know that this is 11 squared. Oh, but 29 is not a perfect square. So that is not a rational number. Root 25 is 5, but square root of 50, well, if it were 49, it would have been rational, but it's 50, so it's not. Square root of 36 is 6. Square root of 225 is 15. Yes, 6 plus 15 is 21. That is a rational number. And of course, if you come here, square root of 5 is not rational, so it has to be 3. Here I had some stuff written. Oh, by the way, this was solved because this was one of the things I was, a few days ago, I was explaining it to one of my students that I tutor. So I wrote X and Y here, and I told them this is, anyway, this is Y is the correct answer. But so just forget that. And I had some calculations and stuff that I explained here, so I tried to cover it. I don't know why we picked this problem specifically, but we are not solving the test. The math department needs to buy new textbooks and laptops for the computer science classroom. The textbooks cost $116 each, and the laptops cost $439 each. If the math department has $6,500 to spend and purchase 30 textbooks, okay, how many laptops can they buy? So, well, they have 6,500, right? Or so what they spend has to be less than or equal to that if they only have $6,500. Now they got 30 textbooks, and 30 textbooks is 30 times 116, and they don't know how many laptops. So if we call that L, for example, for laptop, I say plus 439 L. Now, this is 48, 348, so 3480 plus 439 L has to be less than or equal to 6,500. I'm going to subtract 3480 from both sides. So that would be 0203. So now they have $3,000 to buy laptops. So to find how many laptops they can have, we divide by 439. And we use the calculator and get 3020 divided by 439. It's 6.9. So we don't round. You have to think about it. 7 laptops would be more than 3,000. They don't have this money. So you always run like round down or just take the integer portion. So the answer is 6, not 7. Many students would select 7 because it's very close. It's 6.9, and they say, oh, 6.9 means 7. No. Theoretically speaking, they don't have the money to buy 7. See, 7 times 349 is 2443. What? 7? It's 439, not 340. I'm dyslexical. Okay. So 3,073. They are short by $53. Yeah, somebody can pay from their own pocket, but no. Theoretically, we can't get more than 6. Okay. What is the solution to the equation 3/5 x plus 4/3 equals 1.04? Again, we can distribute first. So you get 3/5 x, and then 3 and 3 would cancel, and that would be plus 4/5, right? The 3 and the 3 cancel, equals 1.04. Now I can write this as 0.8. Well, you can use the calculator, of course. Plus 0.8 equals 1.04. And then I'm going to subtract 0.8 from both sides. So I get 3/5 x. Oh, I subtract. Why did I divide? Subtract. So I get 0.2, right? Yeah, 0.2. And then you multiply both sides by 5/3. 0.2 is 2 over 10 or 1/5. These cancel, and you get x equals 1 over 1/3, right? I did something wrong. Did I do the math correct? 4/5 is 0.8, so that's 0.84. What? I'm subtracting. I subtract point, so this is 0.28, right? I subtract 0.8, not 0.88. So times 5 is 1.4, 1.4 over 3, which is 0.4, and 2/3, 667. I don't even have that. What did I do wrong? That's so funny. 1.04 minus 0.8 is 0.284. Yeah, I said 0.88. So 0.24, that would be 1.2, or this would be 0.4. Oh my God. Oh my God. I'm so sorry. This is horrible. How do you miss that? Okay. The area of the rectangle is represented by that, which expression also used to represent the area of the same rectangle, meaning when I multiply them, I get the same result. Okay. So you can see that this one gives you 3x squared, okay? Plus 2 minus 12, so minus 10, yeah, it's 1. We were lucky. Notice that these are positive, so they would result in a positive constant, and this is negative 8. This one will give you negative 8, but you have negative 6 plus 4. That doesn't add up to negative 10. Same thing, 6 minus 4 is 2, not negative 10. 1 is the only one. Which relation doesn't represent the function? If you have a table, you look at any value of x that repeats. If none of them repeat, then this is okay. Okay? If you have a graph, you use the vertical line test. No line intersects the graph in more than 1 point, so that's okay. Y is a square root of x plus 1. So x, of course, has to be greater than negative 1, but for every single value of x, there is a unique value of y. There is no, you cannot find two values of x that give you the same y. I'm sorry, no value of x that will give you two values of y. So that's I will start. The other one would be a one-to-one function that you will learn about later. But when you come here, you see that, oh my God, if I give you x is 1 and I ask you what is y, is it 4 or 5? It cannot be more than one thing. I can have 1 and 2 going both to 6, but I cannot have a single x as each one of those going to multiple values of y. So that is not a function, that's a relation. So we circle that as it's already circled. What do we have here? Brittany is solving a quadratic equation. Her first step is shown below. So first of all, she switched the 10x to make it in order, like square and then linear and then constant. So what do we call that? That's the commutative property. You can change, you say 2 plus 3 is 3 plus 2, right? So that's correct. We didn't add any, and here it's distribution, right? Distributed 3 times 2x. So it's not addition property of equality. That's when we add the same amount to both right and left. Commutative is correct, but we don't know if it's the only one because it's not the only one. Multiplication property of equality is when you multiply or divide both sides by the same constant. That's not, so it must be the third. Distributive property, yes, of multiplication over addition. Yeah, multiplication over addition. So it's 2 and 4. 2 and 4 is the last option. The graph of y equals 1/2 x squared minus x minus 4 is shown below. The points -2 and 0, 0 and -4. So this is A, this is B, and C is 4 and 0 are shown, and all of them are. Which of these points can determine the zeros of the equation? Zeros, as I told you before, the word zero of an equation, or the solution of the equation, or the x-intercepts of the equation all mean the same thing, or the roots of the equations. These four things mean the same thing. And these are the only two zeros, right? This one is not. That's a y-intercept. So, which ones? This is A, right? This is A. 0 and -4 is B. And this is C. So A and C only. Okay, number 10. Given the parent function f of x equals x cubed, g of x equals that is the result of what shift? The way I do it is slightly different, and I explain it in videos in the math playlist. But as you should know, I moved 1 unit to the right and 2 units down, right? So 1 to the left, no. 1 to the left, no. 1 to the right and 2 down, yes. 1 to the right and 2 up, no. That would be +2. They give you C and D, and they want C minus 2D. Okay, so you write C, which is 2a squared minus 5, and then you subtract 2 And then between parentheses, you enter d, which is 3 minus a. So you get 2a squared minus 5. You distribute the negative 2, so you get negative 6 and positive 2a. You rearrange them, so you get 2a squared plus 2a, and negative 5 minus 6 is negative 11. And again, that's C, 3, right? Same as that. So 3 and 3. Mark bought a new laptop for $1,250. He kept track of the value of the laptop over the next 3 years, as shown in the table below. Which function can be used to determine the value of the laptop for X years after the purchase? This is the same as giving you a table and tell you this is an exponential equation. What is the constant outside AB to the X, right? What is A? Which is at time 0. So first of all, we see that if you divide, forget about the 0. So 80 over 100 or 8 over 10 is 0.8. 64 over, you know that 8 times 8 is 64. So 64 divided by 8 is, again, 8, but divided by 80 is 0.8. So this is 0.8 multiple, and this is 0.8. So I can exclude 1 and 3 because they have 1.2, meaning the numbers increase, not decrease. Okay, but which one of them? Yes, it's 1250. Why 1250? You divide 1000 by 0.8 to get the value after at purchase, 0 and 1250. Yes, 1250. So at time 0, if you say 1250 times 0.8 to the 0th power, anything raised to the power of 0 is 1. So 1250 times 1 is 1250. And then when you substitute X equals 1, because that's 1 year after the purchase, you get 1250 times 0.8, which is 1000, and so on and so on. So you don't pick this one because you have the first number as 1000, but that was in year 1, not in year 0. Okay, that's the initial portion. A, B to the X. A here is the initial value for any exponential. It doesn't have to be money. It can be, numbers. It can be anything. Okay, so I didn't circle that. I said that's the correct answer, but I forgot to circle. Nice. Let's move. The height of a ball Doreen tossed into the air can be modeled by the function. The height of the ball equals negative. It has to be negative because it's going up. So it's a parabola opening down. Plus 6x plus 5, where x is the time, so it's t, so to speak, in seconds, and h of x is the height in meters. The number 5 in the function represents what? Yes, the initial height. When the time was 0, these two would give you 0, and the height is 5. So she started throwing the ball or tossing it in the air 5 meters above ground. So probably she was on her porch or something and throw it. So it's the initial height of the ball. Yeah, it's not a time. Of course, the time is x. This one doesn't have x. It's not the maximum height. The maximum height would be after 6 over 9.8 seconds. So that's okay. Number 14. The function f of x equals to x squared plus 6x minus 12 has a domain consisting of the integers from -2 to +1. So it's not the whole parabola, but I just plotted from -2 to 1 inclusive. Which set represents corresponding range values for f of x? Well, all what you have to do is to substitute, use a calculator, and get 2. So f of -2 equals 2 times, and again, like we did before, -2 squared plus 6 times -2 minus 12. -2 squared is +4 times 2 is 8. 6 times -2 is -12, so that's -4 minus 12 is -16. Which one of those? Of course, why do you have 3 this is like a continuous function, so it has to be 4. Well, just to be on the safe side, you do f of 1. So 2 times 1 square plus 6 times 1 minus 12. 1 square is 1, times 2 is 2. 6 times 1 is 6 for a total of 8, minus 12 is negative 4. Okay? Some students, they put this because they may not understand the meaning of domain. So they say, okay, what about f of x equals 0? You get 0 plus 0 minus 12. Oh, so it must be this one. So why do you do negative 2, 0, and 1? Why didn't you do negative 1 also, right? Anyway, which equation has the same solution as that? So definitely here they were completing the squares, right? So to complete the square, I'm going to add 33 to both sides first. Or you can do it in a different way, but you have x squared plus 8x equals 33. So I have to say, how do I make that a complete square? You take the middle value, you divide it by 2, and then you square it. When you divide it by 2, it becomes positive 4. So the result at the end would be x plus 4 squared. So I can ignore 2 and 4. It must be one of these two. And then you add 16. If you add 16 to the left-hand side, you have to add 16 to the right-hand side, equals 49. So it's 1. Very simple. Just complete the square. Okay. The table below shows the weights of Liam's pumpkin, LW, and Patricia's in PW over a 4-week from 6 to 9. So 6, 7, 8, and 9. W here represents the number of weeks. That grows at a constant rate, and you can subtract one from the other. So you see that increases by 3.1, 3.1, 3.1. So that's an arithmetic sequence. This one increases by 52%. So you multiply that by 1.52, right? Increases 52, 152. And probably they are just rounding. So to check, you can say 2.5 times 152, and you get 3.8 times 1.52. You get 5.778, which rounds to 5.8. You get 8.816. Or even if you multiply that by 152, it should have been the correct one. You get 8.8 anyway. Assume the pumpkins continue to grow at these rates through week 13, 10, 11, 12, and 13. Liam's pumpkin will weigh, well, so they tell you that Liam's will still be higher during weeks 10 and 13, or Patricia's will be higher in both weeks 10 and 13, or Liam's would be higher at 10 and Patricia at 13, or Patricia at 10 and Liam's in 13. So what we have to do is to say, okay, what is it at 10? I'm going to add 3.1, so I get 14.8, or I add 4 times 3, so 12.4, which would be 24.1. So basically you would say 11.7 plus 3.1 to get this. But if you want to go from 9 to 14, you say 11.7 plus 4 times 3.1, and you get 24.1. Or 14.8 plus 3.1 times 3, so you can get that easily. To get week 10, I multiply 8.8 times 1.52, and I get 13.4. So Liam is higher, so I can exclude 2 and 4 because it says Patricia will weigh more in week 10, right? Now, how do I find this? I can take the 8.8 and multiply it 1, 2, 3, 4 weeks, so times 1.52 raised to the fourth power, or 13.8.4 raised to the third times 1.52 raised to the third power. Oh my God, that is humongous, right? 47. Of course, because that you multiply, it's like you're adding 50% of what you have. 60%, 50% of that is like 6.5. So you right there, you are at 20 in week 11, which is very close. So 20, that would be probably 30. And then the 30 will be roughly 45. And yeah, you get 47, which makes sense, right? So Liam was higher at week 10. And no, Liam way more in 10 and Patricia in week 30. And after that, it would be more if they keep going at the same rate. Patricia's weight will always be higher, her pumpkin's weight. The function f of x is graphed below. The domain of the function is what? Some people would say all positive real values. Well, it's not all positive. I mean, all real. Maybe people would say all real values because, you know, they don't notice that the function starts at -1. Yeah, it extends to infinity in the domain, but it starts at -1. So x must be greater than or equal to -1. It's not greater than or equal to 0, or else I'm not counting this part. It's not all real numbers because that goes from -infinity to +infinity, even though the x here is -1. And of course, that's ridiculous, positive integers. So what about the value between 0 and 1? Don't you count those? It's just 0 or 1 or 2 or 3? No, cannot be integers. Okay, which pair of equations would have -1 and 2 as solution? Well, if I substitute x is -1, I will get 2 for y. But if I substitute -1, 2 to the -1 is 1/2, so it couldn't be this. Let's move to the second one. -1 minus 1 is -2, but y is 2. See, if you substitute y equals -1 minus 1, you will get -2, so it couldn't be this. In the third one, -1 square is 1, minus 3 times -1 is +3, so you get 1 plus 3 is 4, minus 2 is 2. Okay, so -1 times 4 is -4, plus 6 is +2, so yes, it is this one. Which function could be used to represent the sequence 8, 20, 50? You can see that that's not an arithmetic sequence, that is a geometric sequence. If you divide 20 by 8, you get 2.5. 50 by 5 by 2 is 2.5, and so on and so forth. If A1 is 8, how do I calculate the next one? Notice that these, you are adding stuff, so it couldn't be that. It's definitely this one because the ratio is 2.5. So A2 would be 2.5 times A1. A1 is 8, and 8 times 2.5 is 20. A3 equals 2.5 times A2. A2 is 20, 2.5 times 20 is 50. So that will show you, you know, recursive relationship. Number 20, still have 5 more. The formula for electric power P is P equals I squared times R. Okay, P equals I squared times R. I being the current and R the resistance. So they want the formula for I. Like you solve for anything. Like assume P and R were numbers and you are solving for I. First of all, I'm going to divide by R both sides. So I get I squared. I get I squared equals P over R. Then I will take the square root of both sides. Don't tell me plus or minus because the current is a positive value. So I get I, the square and the square root cancel each other. They are inverse functions, and you get the square root of P over R, which is 2. The function f of x and q of x and p of x are shown below. When the input is 4, meaning when x is 4, which functions have the same output value? So let's calculate. When x is 4, 1, 2, 3, 4, y is 1, 2, 3. So here y equals 3. When x is 4, y is 3. When x is 4, I get 4 minus 1 square minus 6 equals 3 square minus 6 equals 9 minus 6 equals also 3. So all three of them, f of x, q and x of x, and p of x, all of them gives me the same value, same output. Using the substitution method, Vito is solving the following system of equations algebraically. Okay, so if you are using substitution, of course you would substitute for y. Why would you substitute with something that will result in fractions? So I would say y equals, I'm going to subtract 3x from both sides. So negative 3x minus 4. And then, like we did with the function, every time I see the letter y, I'm going to replace it with this right-hand side. So I have 2x minus 3 times negative 3x minus 4 equals negative 21. Oh, do they have that? So they didn't solve. They just, oh, which one? Oh, the top one. 2x minus 3 times negative 3x minus 4 equals negative 21. It's just the first step of the substitution. Materials A and B decay over time. The function for the amount of material A is A of T is 1000 times 0.5 to the 2T, and for the amount of material B is that where T represents, so the first one is 1000 times 0.5 to the 2T, where T represent, on which day will the amounts of material be equal? So you have to say equal and then solve for T. Maybe we'll use the calculator. 0.25 T. Oh, I have 1000 and 1000. So I'm going to divide by 1000 both sides. And I have 0.5 and 0.25. Do you see something? 0.5 square. 5 square is 25, so point is 0.25. So I can write this as 0.5 to the 2t equals 0.5 square, because 0.5 square is 0.25 to the t. And you know that if I have x to the a raised to the power of b, it's x to the a times b. So this becomes 0.5 raised to the power of 2t, which is the same, meaning they will always be equal. It's the same equation written in two different ways, right? So every day. The following conversion was done correctly. What were the final units? Well, this is the easiest thing. You don't care about the numbers. They told you it's done correctly. So don't say, oh, is the mile 52? Yes, it is. Is the hour 60? Yes, it is. So all what you do, which is the easiest problem ever, is that you treat the units like you treat variables. You say, oh, I have hour in the numerator and hour in the denominator, so I cancel them out. I have a miles and mile. Yeah, you say there is an extra S, but they are the same unit, right? So you cancel them out. You have feet and foot. One is plural, one is singular, same unit. I don't care, right? It's one. So it's inches per minute. See how easy it is? Inches per minute is number 4. We are done. Yeah. And that's part 1. So I will see tomorrow if we can finish both 2, 3, and 4, or we'll do 2 tomorrow and then 3 and 4. I don't know. 1, 2, 3, 4. There are 8. Oh, no, they are. Wait a second. Is that part 2? I'm missing something. I don't have parts 3 and 4. How? Okay, I'll print them out. And probably I'll do only part 2 tomorrow and then 3 and 4 the day after. Okay, I don't know why I got that missing, but I'll take care of it. Don't worry. Again, as usual, if you have any questions or comments, please don't hesitate to ask me. I'll get back to you as soon as I can. Otherwise, wish you all the best and hope to see you soon.